Alright guys, what I want to do now is go through a word problem and teach us how to write an equation from a word problem. Now the type of a linear equation we'll be focusing on here is one in the slope-intercept form. Now there's other ways to do it, but for now that's the one that a lot of people are familiar with, so we're going to start with that one. Okay? So let's go ahead and read the problem. Usually the first thing that we need to do is understand what's going on. So we've got Mr. Kimball. He receives a $3,000 annual salary increase on the anniversary of his hiring if he receives a satisfactory performance review. So if he does a good job, he's going to gain an extra $3,000 in his salary every year. His starting salary was $41,250. Write an equation to show K, Mr. Kimball's salary after every Y years. Okay? So we need to show first, we've got Y being the number of years, and then we've got K being Kimball's salary. And I believe it's a K because of Mr. Kimball, but this will be his salary. Alright, now this is going to be a little bit confusing because it's told us that Y is the number of years, but please recognize that the independent variable here is the number of years. The dependent variable is the salary. The salary depends on how many years. So since this one is the dependent, then that means that it is going to be the Y value in our equation, and that Y is going to be our X value. Okay, so when we think of our normal X and Y, that's how it's going to be, which is going to be a little bit confusing because Y is now the number of years. But this is just to show you that sometimes you can have something a little bit different. The variables can be switched up. So what we're going to do is we're going to go ahead and write out our equation. We want Y equals mx plus b. Now remember that Y is actually going to be K, our salary, and X is going to be Y, the number of years. Now let's go ahead and look at what we have. We understand that the starting salary is $41,250 and that it's changing by $3,000. Now you may be able to pick off the slope and intercept from this information, and if you can, that's wonderful. But if you can't, here's something that we can do to help us out. Okay, we're going to make a table, just like we used to when we're plotting graphs. So we've got X, which is the years, and then you've got Y, which is your salary. Okay, so X years, when he's been working for 0 years, his salary was $41,250. Okay, 1 year later, assuming that he gets the satisfactory performance review, then he's going to get an extra $3,000. So that year he's going to be making $44,250. After 2 years, we're going to add $3,000 again, $47,250, right? So we're adding $3,000 each year. That's what it's told. So I didn't really have to do any big technical thinking to get that. Now from that point, we need to be able to get the slope and the y-intercept. Now you may recognize that this is going to be an arithmetic sequence where I have a constant difference of 3,000. So that would be our slope. If you didn't recognize that, however, we would just go y2 minus y1 over x2 minus x1. And so in order to do that, you would just take 2 points. This would be 1 point right here, 0, 41,250. And the other would be 1, 44,250. And so I'm going to go 44,250 minus 41,250. And we're going to then go over x2, which was 1 minus 0. And you'll notice that that gives us 3,000 over 1, which is 3,000. So that's my slope, right? So once we have our slope, we can plug that in. Y equals 3,000 x plus b. Now if you watched my former video, then you could tell that once you have the slope, all you need to do is put in an x and y. The other thing you can do here is recognize that when x is 0, y is 41,250, which means that is the y-intercept, because the y-intercept is the value when x equals 0. So y equals 3,000x plus 41,250, which then means we can put the k in for the y and the y in for the x and use the same numbers, and you're done.